The Train Control and Monitoring System, also known as TCMS, is composed of multiple communication buses, multiple subsystem-specific control units, and safety train lines. In the context of the Shift2Rail initiative, the CONNECTA-2 and Safe4RAIL-2 projects have been collaborating towards a next-generation TCMS based on four main technologies: Driveby Data, Functional Distribution Framework and Application Profiles, Simulation and Virtualization Framework, and Wireless TCMS. Trains have come a long way in the last 50 years, but today's onboard data communication systems still do not meet the requirements for future train digitalization. Driveby Data technology is able to interconnect all onboard devices from mission-critical devices to video surveillance and infotainment with one common high-performance communication system. The following features make Driveby Data a key element for future train development: gigabit data speeds within vehicles and over the train backbone, safe train inauguration for discovering the current train configuration and train integrity, reliable deterministic and safe data transmission with time-sensitive networking. CONNECTA-2 and Safe4RAIL-2 contribute to an ongoing railway standardization process for the functionality of exemplary train subsystems so that the TCMS can communicate with supplier subsystems in a standardized way. These interfaces are called application profiles. The TCMS controls, for instance, the heating, ventilation, and air conditioning, or HVAC, using standardized interfaces. With this approach, HVAC end devices and the HVAC control will be integrated in the same way even though they come from different railway suppliers. This concept is additionally intended to reach functional interoperability between consists, or train units, from different railway vendors. This functional open coupling is a feature demanded by operators to increase the flexibility in using their fleet. The Functional Distribution Framework supports a homogeneous way of performing the implementation, integration, and safety argumentation for train subsystems across different system integrators. In this way, subsystem suppliers can make use of the same source code for the implementation of their subsystems for different integrators. This approach allows the required alignment of integrators and suppliers in the European railway sector with the different operators. This reduces the need to design a customized solution for each project. The Simulation and Virtualization Framework allows testing of different train applications and technologies without the need to have all the real subsystems in place. In the case of CONNECTA-2 demonstrators, supported by Safe4RAIL-2, real hardware dedicated to communications and TCMS control are integrated, whereas the rest of the equipment and subsystems of the train are simulated in a virtualized environment. This offers a controlled, functional scenario in a reduced space. This means a large number of fully automated and simulated tests can be done before costly and time-consuming real environment testing. Besides reducing and anticipating risks, virtualization clearly contributes to significantly speeding up verification and validation activities. Essentially, the Simulation and Virtualization Framework comprises the configuration tools, requirements traceability tools, test scripting tools, and results recording tools to set up and carry out tests in an automated way. The software components running the models that simulate the different train subsystems and the electromechanical environment between them. The development of a virtual train in which selected systems are executed on a single PC, as in a real train, considering different combinations of train types and allowing speeding up of the development processes. The execution of remote hardware in the loop tests to control the performance of real equipment located far away from the main site. Wireless technologies in TCMS aim to eliminate the cost of cabling and add flexibility when adding new subsystems to existing fleets. The new wireless train backbone provides a train-level wireless communication bus which is composed of a set of nodes installed in each consist. Each node is divided into two functional blocks: the adapted Ethernet train backbone node and the radio devices. While radio devices handle the wireless communication and cybersecurity requirements, the adapted Ethernet train backbone node implements railway-specific functions such as train inauguration, adapted for wireless domain providing train-level end-to-end communication. Different radio devices have been used for handling the two types of traffic in the train backbone, the TCMS traffic and the OMTS traffic. The CONNECTA-2 and Safe4RAIL-2 projects have also deployed a wireless demonstrator for the internal communications inside each consist, the Wireless Consist Network. This demonstrator enables the evaluation of the wireless technology in reference to the train network communication standard IEC 61375. Laboratory tests have been carried out to ensure that communications are robust and deterministic enough for a fully wireless consist network. With the support of Safe4RAIL-2, the CONNECTA-2 project has designed and implemented test benches in different laboratory environments, or demonstrators, for the proof of concept, demonstration, and validation of all these leading-edge technologies, architectures, and solutions proposed in the next generation TCMS. The first laboratory demonstrator is for an urban train application, which is composed of 2 different cabinets emulating 2 coupled consists. The second laboratory demonstrator is for a regional train application comprised of 3 consists from different partners, thus allowing testing for functional interoperability. Both urban and regional demonstrators have been used to test these technologies with a Technology Readiness Level, or TRL, 4, and will help to improve these solutions with the aim of having market-ready products with TRL 9 in the future. The CONNECTA-2 and Safe4RAIL-2 projects have validated in a laboratory environment several advanced technical solutions for next-generation TCMS. In the future, further steps will be taken to scale the technology readiness level up to 7, paving the way for the development of market solutions.